So for recording purposes, today is the beginning of organic chemistry. I'm hoping to do two things: the introduction to organic chemistry plus something called alkenes. Okay, let's get started. So organic chemistry, we're going to break it up into 7 categories. Yes, quite a lot of categories when it comes to organic chemistry. And the 7 categories I normally break it up in and is alkenes. The second one is alkenes. Now I want you to look at number 1 and number 2 properly. Yeah? On first glance, it looks like the same word, but it's not the same word. One is alkenes, it has an A over here, and the other one is alkenes. Real subtle difference between the two types of organic materials, okay? And of course, the rest of them have seriously different names. It's not easy to mix it up. Like the third one is alcohols. The next one is called alkanoic acids, esters, soaps and detergents. That's right, the same soaps and detergents you bathe and wash your hands with. Those are organic materials. And something called cracking. Obviously, I don't expect you to know what any of these 7 things are. I'm just telling you, hey, these are the 7 things we're going to meet up eventually. All right, so let's move on. Like I said, there's no need to take notes today unless I tell you to take down something, because I gave everyone the slides to print out already. So we can speed up class. So when you are printing out the notes, right, or when you eventually print out the notes, this here is a table, kind of like summarizing almost everything in organic chemistry. It's like a summary chart. Now, what usually happens after your teacher explains the whole of organic chemistry, right? They might take the teacher an entire term to explain the whole of organic chemistry. Students usually ask, Miss or Sir, you have anything you can give us to kind of like summarize those 3 months of work? And your teacher will print this table out and give it to you. Now, at first glance, this table looks very, very what? Intimidating, right? It looks super, super what? Intimidating. And you should be, I mean, I don't blame you. But the only reason it looks intimidating is because no one explained alkenes to you, alkenes, alcohols, alkanoic acids, and ester. They haven't explained any of those things to you. So it's going to look intimidating. Don't worry. By the end of the 5 weeks, when you look back at this table, you'll be smiling. You'll be like, oh, all right, this table finally makes sense. So let's move on. I know some of y'all are probably asking, I'm using the word organic chemistry. So your first question in your head is, well, what is an organic compound? Sir, it hasn't really explained what is an organic compound. He's just given us the different categories or the names of organic compounds. I know you all want to dig into it and get a better idea of what it is. I will get there, don't worry. But I have to make some assumptions today. One assumption is that everyone at least knows a little bit of the periodic table. There are 8 groups. So help me answer some quick questions here. What are the elements in group 7 called? What are the elements in group 7 called? Right. So you're going to be hearing about group 7 a lot in organic chemistry. Those are the halogens: fluorine, chlorine, bromine, and iodine. Those are your halogens. Quick question. Halogens have how much valence electrons? In case you cannot remember what a valence electron is, that's how much electrons it has on its last shell. So valence electrons are the amount of electrons on its last shell. And the answer should be obvious because all halogens are found where? In group 7. And the reason it's placed in group 7, it's because it has 7 outer electrons. Okay, so I'm just doing a quick example here. Chlorine will probably be one of the more popular halogens you're going to encounter today. So let's say you have a chlorine atom. I can't remember. I think chlorine has 3 shells, right? I'm not going to draw all 3 shells for you, right? I'm just going to draw the valence shell. So, like we just explained, chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, and 7. Is chlorine what we consider a happy atom? Is chlorine happy? And the answer is no, he's not a happy atom. He's very sad. Why is he sad? Because his outer shell is not filled. Other than the first shell, the rest of the shells, like the second shell and the third shell, need how much electrons to be happy? For it to be full, how much electrons should a second or third shell have in order to be happy? It should have what? 8. So that means for chlorine to be happy, it has to gain 1 extra electron. So chlorine gains an extra electron in order to be what? Happy. All right, now I know we did all of that last term, but like I said, all of these things you're going to hear, it's going to come back to kind of haunt you today when we start to talk about organic compounds. So that means everybody in group 7, fluorine, chlorine, bromine, and iodine, they are missing 1 electron, and they will always try to steal or get 1 extra electron to achieve a full shell in order to be happy. Great. How many valence electrons does carbon have? How much valence electrons does carbon have? Carbon is going to be super popular. In fact, all organic compounds, every single organic compound must have carbon. Without carbon, it's not an organic compound. So I would say in organic chemistry, the most important atom is actually carbon. And a lot of y'all have the answer, correct? If I have carbon, right? Right? I'll just put C for carbon. I'll just put 1 shell here. That's not, I don't want to draw a circle around the shell. Right? So this here is carbon. And you all told me carbon has 1, 2, 3, 4. And you're correct because carbon is in group 4. So if carbon was to bond with hydrogen, what kind of bonding would take place? We want to combine carbon with hydrogen. What type of bonding would take place? Ionic, covalent, or metallic? You have 3 choices. But which one is the correct one? Right, it has to be covalent bonding. In case you can't remember, covalent bonding happens between 2 non-metals. Carbon is a non-metal. Hydrogen is also a non-metal. So it's covalent. So that means if hydrogen comes here, remember hydrogen has what? 1 outer electron, because hydrogen is in group 1. So hydrogen will covalently bond with carbon. In fact, I know it kind of cramped here. It will take 4 hydrogens to bond with 1 carbon. And you notice why it's 4? Because when 4 hydrogens bonds with 1 carbon, then carbon ends up with how much? 8 electrons. Look at it here. 1, 2, 3, 4, 5, 6, 7, and 8. Now, here's the thing. This diagram looks a little bit too complicated. Suppose you had to draw that 10 times in the exam. It's going to be a real headache to draw. So there's a little shortcut to drawing this. You see every shared pair of atoms? You see how the X belongs to the carbon and the dot belongs to the hydrogen? That's a covalent bond. This is how they will draw it. They will draw it like this. H here, H here, H here, and H here. Each line represents a pair of electrons. So this line here represents an X and a dot. So this is 2, 4, 6, and 8. So that is how we are going to be drawing it in organic chemistry. Because you see these diagrams, we're going to have to draw it so much times, we have to find a little shortcut to help us out. Okay? So just to answer the last two questions there, which is obvious, how much valence electrons does carbon have? 4. How many hydrogens will bond with one carbon atom? The answer, as you all know, is 4. Also, keep in mind, when we are doing organic chemistry, carbon must always have 4 bonds coming out of it. Must always. 1, 2, 3, 4. If I do any diagram and my carbon doesn't have 4 bonds touching it, tell me, sir, you made a mistake, and check back my work. Right? So I'm going to ask you all to keep an eye on me. Everybody with me so far? This is simple stuff from September, but it's worth repeating, obviously, right? I think everyone should be okay here because real people answer the questions, right? So that's good, right? And guys, for those who came in late, get involved in class. Huh? All right, so I think we already answered this one here, and I already did this. This is the same diagram here. You see carbon, and it has the sharing pairs of atoms, and I already mentioned the shortcut to drawing this, and I already mentioned covalent bonding happens between carbon and hydrogen, right? So it seems that I explained this slide a little too early, but that's okay. Let's go. All right, give my mouth a little rest. So let's play the game here. You'll see the instructions here. Everybody who chose the blue and red team, you get to choose 3 letters. All the other teams, unfortunately, only get to choose 2 letters. So send your 3 letters and let's hope you get your colored gems. So team red and blue, choose any 3 letters. Yellow and green, choose only 2 letters, right? Remember, you can only collect the color of gems that of your team. So if you're on team green, you can only collect green gems. You can't collect any other color. Let's see if you have more luck today. All right, let me know how much gems you got and write it down, because you need to keep track of all your gems. Let's hope you had a little bit more luck today. Let me know how much you got. All right. So this one here is very, very simple. Just remember your diatomic molecules. Remember things like hydrogen, nitrogen, but the list is over here, right? I don't want to repeat the same thing here. A lot of molecules, when it's neutral, it exists as a pair. They're called diatomic molecules. And that includes all the halogens, fluorine, iodine, chlorine, and bromine. All of them for sure are diatomic, right? So I'm not going to spend too much time here. Anytime I see a diatomic molecule and it needs to be diatomic, I'll just remind you. I'll just kindly remind you. So what are organic compounds, right? How do you know when you watch something or the chemical formula of something? How do you know whether it's an organic compound or not an organic compound? And I need you to memorize this how I say, little definition here or explanation for the CXC exam. An organic compound is any member of a large class of chemical compounds. That just means there's a lot of different types of organic compounds whose molecule contain carbon. Now, usually once something contains carbon, it's classified as organic, but there are some exceptions, and those would be carbides, carbonates, and carbon oxides. Those are the only things that have carbon, but they are not organic compounds. So things like carbon dioxide and carbon monoxide, these are not organic compounds, even though they have carbon. Carbonates, like calcium carbonate, this is not an organic compound. So most people know what a carbonate is, and most people know what a carbon oxide is. But most people don't know what a carbide is. So I'll put some examples: calcium carbide and silicon carbide. So I have two examples of carbides here. Anything else usually that has carbon, it is an organic compound. All right. So please remember this definition for the exam. You usually get about 2 marks for quoting it back for the examiner. So let's move on, right? And here are some everyday examples of organic compounds you can find right around your house. How much of these things look familiar, right? I think almost everything here looks what? Familiar. Asphalt, that thing on the road, candles, coal, detergent, mothballs, nail polish remover, natural gas, right? That thing we take out of the ground and provides the most money to Trinidad and Tobago, right? Rope, plastics, all of these things are organic compounds. Now, in the exam, if the examiner asks you to list a few examples of everyday organic compounds, he might just ask you for 3 here. I list about more than 10 here. But the truth is, he might just ask you for 3. Okay? Great. Let's move on. Right. So, what we're going to start doing now is start naming organic compounds, right? And obviously, we can't do all 7 at the same time. Obviously, we're going to start with the first one, Mr. Alkanes. Now, when we are naming organic compounds, whether it's alkanes, alkenes, alcohols, or whichever one, there's a certain method of naming it. Remember, all organic compounds have carbon. Any organic compound that has 1 atom in it, its name will start with meth. If it has 2 carbons in it, you can bet all your money, its name will start with F. 3, its name will start with prop. 4 is but. 5 is pent. And so the list goes on. Okay? So just by looking at the name of a particular organic compound, you can actually predict how much carbon atoms it contains. Okay? Now, some people are going to ask me, does CXC really go up to 10? I believe it actually goes up to 8, right? But in the older past papers, it had 9 and 10. So I just included the 9 and 10 one time just in case. And don't worry, this table, I'm going to have it on most slides as we go along, okay? Don't let it bug you too much. All right, everybody okay so far? Everything simple? I don't think anything too difficult so far, right? It's just this table in front of you is probably the newest thing that you have seen so far. And you're going to get so much practice on it, so don't worry too much. Let's go. All right, before we dive into alkanes, right? Go ahead, guys. Well, here what? There's a huge mining machine on the planet there. Red gets 2 letters. So the red team, choose any 2 letters. Everyone else, sorry, only get one letter. All right. So let's get this out of the way. I want everyone to get a gem. I hate to see some people with 0 gems. Right? A has 2 red, a yellow, and a blue. So I hope you got some there. For people who chose B, 3 yellows and a green. C, 2 blue, 2 green. And D, 2 yellow, a green, and a red. Some people on 0. My God, that's real bad luck. Somebody got 3 gems. Oh. Somebody on 4. Malachi, you're on 4. Matthew on 4. All right, let's get ready to move on. All right, so we're officially going to start the first category of organic chemistry. So for those who printed out the notes, find this slide, right? It shouldn't be too hard. Its name is alkanes. And on the next slide after that, for those who printed, I hope you're already following with the slides, right? Because you're going to have to write some things on the slides in a little while. So alkenes have a certain general formula. The formula is CnH2n plus 2. What this formula allows you to do, well, one of the things, I shouldn't say one thing, it's one of the things, it allows you to predict how much hydrogens it will have if I give you the amount of carbons. So let's just say I come and tell you, hey, I have an organic compound. It's an alkene. So I tell you the category. It's an alkene. And I come and tell you it has 6 carbons in it. So I am telling you the letter N in the formula is 6, right? Because N represents the amount of carbon atoms we have. Using the formula, I want you all to calculate how much hydrogens it have. The formula to calculate the hydrogens is 2 multiplied by N, and whatever you get, add 2. So 2 multiplied by how much carbons you have, and then add 2. The answer is not 12. Check it back, check it back. I want the final answer for the amount of hydrogens. Remember, to calculate hydrogens, it's 2n plus 2. Right? It's not 18. Check it back. All we're doing, remember, if I come and tell you n is 6, then according to the formula, I'm just replacing n with what? 6. So 2 by 6 plus 2. 2 by 6 is 12. 12 plus 2 is 14. For those who got it wrong, you think you understand it? All you have to do is just, it's a simple maths formula. Vinu, do you understand the mistake there, right? So if it has 6 carbons, then it has 14 hydrogens. And this formula will always, always hold true for alkanes. Try one more now. Let's say I come and tell you I have an alkane with 3 carbons. Calculate how much hydrogens it will have. Everyone should be able to get it correct now, right? Right. It has 8, correct. Because I'm going to use back the formula here. It's 2n plus 2. So I replace it n with what? 3. 2 multiplied by 3 is 6. 6 plus 2 is 8. Real simple, right? Well, it's simple now, right? After it doesn't matter if you get the first one wrong. The point is, most people get the second one correct. You call this, you see, when you write it like this, you call this the molecular formula. When you just simply write the amount of carbons, you put 6 by the carbon and you put a 14 by the H, you call that way of representing it, the molecular formula. Now, when it comes to organic chemistry, there are 4 ways of writing the same exact thing. It's just like maths, you know? And they have more than 1 ways to write the same exact thing. Like, if I ask you how much money you have and you tell me it's $9, instead of saying 9, and you could say 3 squared, and you could also say 10 minus 1, and you could also say 90 divided by 10. Look, I just created 4 different ways of saying 9. The same thing with organic chemistry, right? There are 4 different ways of saying the exact same thing. How much of you all know what an empirical formula is? Well, what is an empirical formula? You don't need to make notes now. Don't take down nothing now. You just need to answer my question. An empirical formula. I just showed you what is the molecular formula. But what is the empirical formula? I'll put molecular over this so you remember. Okay. All right, empirical here. All right. Right, so somebody got it correct. It's kind of like when you simplify the values. Look at this here, 6 and 14. They just pretend 6 and 14 is a fraction. Can you reduce that fraction? Can you reduce 6 over 14? If you reduce 6 over 14, and you're going to get 3 over 7. So if you reduce this, you get 3 and 7. The empirical formula just means you try your best to reduce it. That is all, right? Is the second one, is it possible to reduce the second one, the 3 and the 8? Is it possible to reduce 3 over 8? No. I mean, if it's not possible to reduce 3 over 8, well, you just leave it as what? 3 and 8. Okay? So sometimes it's possible to reduce the molecular to get an empirical, and sometimes it's just not possible. You just shrug your shoulders, don't let it bug you too much. Now, I have a problem with the empirical formula. I've never, ever, ever been a fan of the empirical formula. Don't get me wrong. It has advantages, okay? But you know why I don't like the empirical formula? Let's say somebody now comes to class, right? And I erase this, right? So let me say I erase this and I give them the empirical formula. Is it possible for them to get back the molecular formula? In other words, remember, the empirical formula doesn't tell you the exact amount of carbon and the exact amount of hydrogen. It just gives you the reduced values. So can you, if I give you the empirical formula, can you backtrack and tell me how much carbon it actually had and how much hydrogen it actually had? No. To me, that's not possible because there are so many possibilities, right? I mean, some person might say, yes, it's 6 and what? 14. But then another person might say it's what? 12 and what? 28. If you reduce 12 and 28, you're still going to get what? 3 over 7, right? So to me, if I have to choose between the empirical formula and the molecular formula is more useful to me. All right? And don't worry, I know you're probably wondering, but what is the full structural formula and what is the shortened structural formula? We're going to get to that in a little bit. Okay? Right. So let's move on. Let's move on. Right? Oh, and I just saying it back. Just make sure that you understand all alkenes must obey that formula. If the structure does not obey that formula, for example, if I come and tell you C10H17, is this an alkene? Is it possible to call that an alkene? Yes or no? I come and tell you I have C10H17. Is that an alkene? The answer is no, right? Because if C is 10, then the H is supposed to be how much? If C is 10, sorry, N is, well, the carbon is 10. I'm really supposed to have what? 22. 10 by 2 is 20. 20 plus 2 is 22. So this here is not an alkene because it doesn't obey the alkene formula, right? Great. Right, drawing time, right? Well, for those who printed out, well, you already have it in front of you. First of all, I have 3 different organic compounds here. Now look at all of them, right? Remember earlier I said all carbons must have how much bonds coming out of it? 4. Look at this. And this one here has 1, 2, 3, 4. This one has how much? 1, 2, 3, 4. Even this one, 1, 2, 3, 4. Right? If you look at all the carbons individually and you zoom into each one, you notice each one has how much covalent bonds coming out of it? 4. So make sure, that's the first thing you have to make sure. Tell me something. Is the first one an alkene? Does it obey this formula? Yes or no? The answer is yes. I would think it's yes. Let's see if it obeys the formula. Let me just see if it obeys the formula. It has 1 carbon, so it's C1, right? N is 1. 2 by 1 is 2. 2 plus 2 is 4. How much carbons does it have? 1, 2, 3, 4. Yes, he is an alkane. The second one is also an alkane. Look, it has 2 carbons, right? 1, 2. When carbon is 2, well, when N is 2, 2 by 2 is 4, plus 2 is 6. Do I have 6? 1, 2, 3, 4, 5, 6. Correct, right? And the third one, well, C3, you can just trust me on this. You will get what? 8. Right. So the ones on top, right? These are what kind of formulas? Those are the molecular formulas, where we write out how much carbon it has and how much hydrogen it has. Right. Also, when it's 1 carbon, there's no need to put the 1, right? The 1 is understood, right? But I just put it in as it's the first example, right? But the 1 is understood. Now, you see when you physically draw, you see how I actually draw the carbon and draw out all the bonds here, right? When you physically draw out all the H's and all the C's and you put in all the individual covalent bonds, you call this the full structural formula, right? Now, don't get me wrong, I know the full structural formula. It's a little bit more work. You have drawings to do, but it is give you more information. You see, in the molecular, you're going to see this later on, right? The molecular formula obviously doesn't show you all the individual bonds. To me, when you see all the individual bonds, it is give you a better idea of what is going on in the question, right? Right. Any one of these here, which one of these here, it's not possible. Sorry, there are 2 of them here. Which 2 is not possible to reduce it to get an empirical formula? Well, which 2 here, it won't make sense to reduce it, right? Right. The first one and the last one, the last one, you can't reduce it because 3 can't go into 8 and 1 into 4 is still 4. The only one that you can reduce and get a different empirical formula is the middle one. And of course, if you put this one as the empirical formula, you'll get 1 and 3 because 2 into 6 is what? 3. Right? Let's start naming the alkanes. Let's start naming it. We didn't name any. Here's the cool thing. All alkenes end with the word "ene." The first one has how much carbons and only one carbon? Look at the chart here. When something has one carbon, its name will start with meth. And since it's an alkene, its name will end with "ene." You can't ask for anything easier than that, right? So his name is methene. And it's underlining the "ene," right? So you know all alkenes end in "ene." You think you all can do the next two for me? It shouldn't be too hard. I don't think you're gonna get too much problems with this one. Name the next two alkenes, because we already confirmed it's alkenes because all of them obey the formula, right? Right. Names are coming up on the screen here. Next one has two carbons. When something has two carbons, its name will always start with F. Sorry, I don't know what happened to my voice there. F, right? So his name is F-ene. Right. The third one has three carbons. So his name has to start with prop, P-R-O-P, and it ends with "ene." For those who printed out the notes, adding all of these things that I just added in, right? So I'm going to give you all a couple minutes to adjust or to, what's the word? Annotate your slides. Put in the extras here. Right? You see how much time it could change. It will save, right? Because the slides already have the hard drawings on it. You just put in what? The little extra annotations or extra notes. Let me know when you are finished. Right. You think you all could draw pentene for me or on scrap paper? I know you can't send the answer, but I want you all to take a chance and draw pentene for me. And you know it's an alkene because it ends with "ene. And then it have the word pent. Look at this table here and see if you could figure out how much carbons to start off with to assist you in your drawing, right? For those who doing the drawing inside the slides, my advice is do it in pencil in case they make a mistake, right? Don't put nothing in pen, right? Do it in pencil, and if my answer is different, you just change it, right? Pent has 5 carbons. So, and I know it's an alkene because it ends with "ene. So I know my formula is going to be what? C5, because it must have 5 carbons. Replace the N with 5. 2 by 5 is 10. 10 plus 2 is 12. Right. So I know when I do my drawing, I'm going to end up with 12 hydrogens. So here's the first thing you need to do. Just start off with 1, 2, 3, 4, and 5. So you start off with 5 carbons. And then you start to link them together. 1, 2, 3, 4. And remember, each carbon will have how much links coming out of it? 1, 2, 3, and this one is 4. So if I keep doing the drawing like this, right? If I complete the drawing, any carbon that I look at has 1, 2, 3, 4. And this will naturally lead you to getting what? 12 hydrogens. Because if I put a hydrogen at the end of each link, each available link, I will automatically get 12 hydrogens. Okay? And what you call this again, when you draw out all the links, you call this your full structural, right, drawing, right? Which is plenty, but a decent amount of work. Formula, sorry, formula for drawing, oh God. My mistake, formula. Right. And once again, this one here is your molecular formula. Right. But this one cannot be reduced. So the molecular and the empirical formula will be the same. You can't reduce 5 and 12. Quick question. Wasn't there 4 ways of representing organic compounds? It had molecular. Look back in the list. Empirical and what? Full structural. Right. And one starting with S. The shortened structural formula. Now, I haven't shown you the shortened structural formula. And I'm going to show you this one. The shortened structural formula is you're taking the full structural formula and you're making it a little bit more simple. Look at this here. I'm going to box off some things here. I'm going to box off this section, this section, this section. It's easy to visualize that, right? You just take each section and you kind of like just focus on how much hydrogens it's directly connected to. So the first one is connected to how much? It's connected to 3 hydrogens, right? The next one is connected to what? 2, right? So tell me if this makes sense. Got different color here. What color can you get? So I got a kind of pinkish color. Since the first one, CH3 dash CH2 dash, this one is CH2 dash CH2, and the last one is CH1, 2, 3. Right? Easy enough. You have to put in the H, right? So the one underneath is a simplified version of the one on top, right? You don't draw all the individual 4 bonds and whatnot, right? Oh, sorry, I made there's a slight small mistake, right? Some textbooks will leave out the dash in the middle. So just to clear it up, in some textbooks, it will look like this: CH3, CH2, 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 and CH3. Now, I would consider both of these correct. I like to put in my dash. You know why? Well, when everything's so clustered here, it just kind of mess with my eyes a little bit. I like to at least see some separation in them, right? So I'll put the word or this. I know some teachers are going to do the one underneath and some teachers are going to do the one on top. You just ask your teacher which one they prefer for term tests, right? Update your slide. Everything that I put added onto the slide, put it into your slide now. Right? Let me know when you're finished. I think 2 minutes should be sufficient. All right, so here's what I want you all to do. For octane, I want everything. Just as a practice, I want molecular formula, empirical formula, if possible, full structural formula, and shortened structural formula. It seems like a lot, but I guarantee you it's super easy, right? Now, I know you can't really send the answers for all of them, but at least let me know when you are finished doing all 4 on scrap or on your slide with pencil, right? So all 4 for me: molecular, empirical, full structural, and shortened structural. Good luck. So it's octane. If you look closely here, octane is 8 carbons. So remember the formula for alkenes, and you know it's an alkane because it ends with the word ANE. CnH2n plus 2. So to get the molecular formula, which should be the easiest thing, right, is C8. 2 by 8 is 16. 16 plus 2 is 18. So this is here is your molecular formula. I think this one could reduce, right? Isn't it possible to reduce this one? I think 2 and 2 could go into both of them, right? So you get 4 and 9. That one possible, right? You divide both of them by 2. So this is your empirical formula. All right, so I'll get that one out anyway. Those two should be the easiest. The full structural formula, you have to draw 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? 1, 2, 3, 4, 5, 6, 7, right? And out of each one of these, right? If you have a whole set of colors, it's actually pretty relaxing to draw. It's almost therapeutical, right? So H here, H here, ooh, a lot of H's. Right, so that's the full structural formula. This here, I'll just put full, right? The full structural formula. And the shortened structural formula, well, you put the C here, H, so I'm sticking there, CH3, and then I have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 6. And then the last one has 3 hydrogens. So this is the SSF, as some of you all are saying it, right? Shortened structural formula. How much of you all got everything there correct? So of course, you can update your slides as well one time, right? All right, and it's a little break. So let's see the rules for this particular slide. So a huge rockworm, right, has freed a lot of gems. All right, so there are 3 numbers in the monster's mouth here. Choose any number from 1 to 9. 1 and 9 are included. Choose one number, and once your number appears, regardless of your team, you get 10 extra gems. All right? Choose one number between 1 to 9. 1, 9 are included. Right? All right, so everyone has their, well, most people have their numbers in. Let's see. First number is 3. So if anybody chose 3, adding 10 extra gems, right? If you're on the blue team, adding, 10 blue. If you're on the red, 10 red. You all get the idea. Next one is 5. So 5 is also a lucky number. And the last one is 9. Those are the 3 lucky numbers, right? I see some people are just angry. They're like, what? Okay. So 3, 5, and 9 are the lucky numbers there. Let's go. Oh, If you look at the thing here, a little bonus points. This person who's about to die by the worm has just given 3 gems to anybody in the green and yellow team. So it's a little bit bonus there. So if anybody is in the green or yellow team, you get an extra 3 gems, green or yellows, right? So if you're still on 0, oh my God, somebody's still on 0. Right. Don't worry, have more have more chances. It have more chances. Let's go, let's go. All right, so here's a different slide. Let's see what's going on here. All right, so I don't want to spend too much time on this. I think we pretty much got the hang of this, but anybody who just wants to tell me the name of this alkane, I'm not going to make you do this formula. We had enough practice on this. What's the name of this alkene? This is correct. This is hexene because it has 1, 2, 3, 4, 5, and 6. So 6 is what? Hex. So its name is hexene. Now, one thing I want to point out about alkanes. Now, alkanes obviously follow this formula, right? I guarantee you, since it's C6, the amount of H's will be 14. I can guarantee you that. You can count it up if you wish. But you notice it only have single bonds. Let me explain what I mean by single bonds. It has one line here, one line here. Every time you see a C and an H connected, it's only one line. You call those single bonds. So you're probably wondering, and won't it always be a single bond? No. Sometimes you will see organic things with 2 bonds. Look at this here. You see how I have 2 lines connecting this C and this C? You call this obviously a double bond. Alkenes do not have double bonds. All the bonds will always be single every single time. I just wanted to make that clear, right? Later on, you're going to be seeing some organic compounds with double bonds. Right, now one thing, I just want to go back to the next question, right? You all notice all the questions we did so far. It's just one single line of C. It's just one C after the other. C, 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 right? You call this, I'm not sure what you call it, but the point is it forms a straight line. It's almost like you have a tree, right? And if you have a tree, you have like the main trunk that goes up, right? So that's a tree there. And sometimes in a tree, you just have a branch coming out. I'm sure we all know what a branch is, right? This here, we're talking about the C's, and I don't care about the H's. Focus on the C's. There are no branches. They come like they only have one major trunk. There are no branches of C's coming out. You call this unbranched, which is, to me, is the easy type of questions. If I ask you to name this, you could just say this is what? Hexene, and you get all your marks in the exam. The question on the next slide is not unbranched. It's the opposite. It is branched. So let me show you that here now. You all notice this one here. You have a main line of carbons here. And coming out of it, you have what? A branch. Everyone can imagine this. Think of it like this now. If you put it vertical, this could be the main tree trunk, and this could be the branch coming out. Okay? So this is what you call branched alkanes. And I can prove to you this is still an alkene. I can prove to you this is still an alkene. It's just a branch alkene. How much carbons do we have? 1, 2, 3, 4, 5, and you can't forget him, 6. The one on the branch is 6. So if it's truly an alkane, if C is 6, then by the formula, 2 by 6 is what? 12 plus 2 is what? 14. Count up the amount of H's here. Do we still have 14? Just make sure. Do we still have 14 H's there to go with the 6? Yeah, count it up. Yeah, you're getting what? 14, right? So yes, it's still an alkane. And it's also an alkane for further good reasons. You notice it have no double bonds. All the bonds between, anywhere you see, there's only single bonds. There's no such thing as a double bond in anything here. Now, naming branch alkenes is a little bit more difficult. And this is the naming format here. Don't worry, I'm going to explain it. What you need to do first is look at the main branch. Not the main branch, the trunk. You just start naming it backwards. So we're going to start with this here. But I should probably clear this up here. The main branch, I can't branch, but I'm going to call it the tree trunk. The tree trunk has how much seeds? 1, 2, 3, 4, 5. The main tree trunk, because it has 5, its name will start with pent. So according to the naming structure, the red part, call it pent A. Okay? The next part you have to name is the branch. The branch has how much seeds? The branch has how much seeds? Now, people are going to view this different. The branch has how much seeds? 1 or 2 seeds. Some people will say 2 and some people will say 1. Remember, this is the branch. I know some people viewing this as the branch. That's not the branch, right? The branch is the piece outside, just outside the main tree trunk. So the branch only has 1 seed. When you're naming the branch only has 1 seed. So its name will start with meth. And all branches end with YL. Always. That's what this means. The prefix of the branch, that is how much seeds it have, and you always add YL to it. Then you put a dash. Okay? On which carbon does the branch come off at? Like if you, let me say you're walking here. Here's the first carbon, here's the second carbon, here's the third carbon, and here's the fourth carbon. Doesn't the branch come off the fourth carbon? So some people will say 4 needs to go here, but here's what you have to do. You have to walk from both sides. And which side will you reach the branch first? And if you walk on this from this side, the right-hand side, if you walk from the right-hand side, it could be here's the first carbon and here's the second carbon. So, but if you walk from the other side, it will be the fourth. But from on this side is the second. You always have to choose the smaller number. You have to choose the easiest way to walk to the branch. So the whole name of this thing is 2-methyl, no space, and the word pentane. That's how you name a branched alkane, by following this format. I know you need more practice. Don't worry, I have plenty more practice questions, okay? Update your slides and we'll try another example. Well, I think we deserve a little break before we do a harder question. Oh, this is the one where we do a survey in class, right? So here's what we're gonna do. I'm gonna launch the survey, right? So we're gonna take a poll, a survey in class, and everyone is gonna vote. Well, whatever your team color is, you vote that. So if it's team red, press red. If it's yellow, press yellow. The color with the highest amount of members will get 8 extra gems. So whichever team comes first gets 8 extra gems. The next one gets the second highest amount, gets 4 extra gems. So let's launch the poll. I like this one. I think you all enjoyed this one yesterday. All right. Begin to vote, guys. Choose your team and I will color. I will share the results and we'll see which team comes first, which teams come second. Whoa. All right. So I didn't expect these results, but I'm going to end the poll and share the results. First place is Team Yellow. Everybody in Team Yellow gets 8 extra gems. Everybody in Team Blue gets 4 extra gems. Right? So I guess red and green, sorry. All right. I'm guessing everybody has at least 1 gem by now. I'm hoping everybody. Ah, look, somebody get 4 gems. Right. Kemi, you finally get some gems. Well done. Right. Akil, you have none. I really expected red to come second place, sir. I didn't expect blue to come second place. What are you gonna do? Right. All right, let's go. All right. You think you all can name this one for me? Good luck with this one. I want you all to try to name this one for me. This is a branched alkene. So remember, we always start the naming process kind of backwards, right? The red part deals with the main tree, the tree trunk, the trunk of the question. It has 1, 2, 3, 4, 5, and 6. So 6 is what? Hex. So it's hex, and you have to put in the word in, right? That is this guy here. Now, the branch, right? The branch itself is this guy here. Once again, the branch only has 1 carbon. So his name is meth. And all branches end with YL. Now, where does the branch come off from? I see some people put 5, but remember, you have to start walking from on both sides. Now, if you start walking from on this side, the branch comes off 1, 2, 3, 4, 5. It comes off the 5th carbon. But if you start to walk from on this side, doesn't it come off the first, second one? Doesn't it come off the second one? And you're supposed to choose the smaller of the 2 values. So it's not 5, it is 2. Because if you walk from the left-hand side, the branch comes off the second carbon. So its full name is 2-methyl, no space here, and the word hex 8. For the people who put 5, you understand your mistake? You have to choose the smaller. You walk from on both sides to reach a branch, but you have to choose the smaller of the 2 values. Right. Now you see how I draw this one? Sometimes the examiner draws it like this. You all see the relationship here? Like he just didn't draw every single branch. All he knows is that this carbon has how much? 3 hydrogens attached to it. So sometimes they draw it like this in the exam. You think you can name this? Right? It's almost, yeah, it's almost so close to a shortened structural form. It's a little bit different. But yes, at the end of the day, it's a version of the shortened structural form. You think you all can name this one for me? It is a branched alkene. It is a branched alkene. Good luck. Use red for the tree trunk. So this obviously here is the tree trunk, right? The main part. It has 1, 2, 3, 4, 5, and 6. So he is definitely hex, and you had to put the word in. The branch now, the branch is this part. The branch has 2 carbons, not 3, 2 carbons. 2 is F. So it's F, and all branches end with Y and L. Dash. If you walk from this direction, the branch comes off the first, second, third, fourth, and fifth. But if you walk from this direction, it comes off the first, second carbon. If you walk this way, we have to choose the smaller of the two. So his full name would be 2-ethyl, no space, hex, in. There's no space here between the L and the H. But, and you must put the dash. Yeah, if you don't put the dash, well, it's not 100% correct. For those who got it wrong, right? Just let me know if you see it, right? If you see it. Let's go. All right. So I know we're coming close to the end of class, right? So I know we kind of tired or whatnot, but we're not finished with alkenes, right? The next week in class, we're going to start off with something called isomers. Like, what is an isomer? And it takes quite a while to explain, right? So I'm just letting you know where we're starting off next week, okay? Right? Now, before we go, I just want to do one more before we leave. All right, because it's almost 1:30. Look how fast 2 hours almost passed. All right, so let's look at the rules here. Blue and green teams gets to choose 2 superheroes. So for the blue and green teams, choose your favorite 2 superheroes. Everybody else, the yellow and red, you only get to choose 1 superhero. And let's see how much gems you get. So once again, blue and green, 2 superheroes, and well, everyone else, 1. And then after, guys, give me a count up of how much gems you have in total. Right? And don't forget, for those who have no idea about the slides and where to get it, I will show you after class. All right, let's see it. Whoa. Count up how much gems you got. Remember, you can only collect gems of your color. Somebody said they hate this game. Right. Akil, you finally get gems. It's 3, but you finally get. All right. So once you give me a total, you're free to leave. I suspect the highest amount would be 18 gems. That's the highest amount you can get, I believe, for the entire game. Or somebody at 21, one person at 19, Sebastian 23, Rebecca 23. Oh, all right, guys.